Alright, let's look at this question. This is another question involving finding the equation of a plane that containing two lines. Alright, this case is different where this is said to they ask you to find the equation of a plane, right? But this plane containing two lines, right? Containing this line and also this line. So it means we have two lines on the plane, and this two line lies on the plane. So how are we going to solve this type of problem, right? So let's say if you have a plane, right? Let's say this is your plane, and this plane containing two lines. The information given is this plane containing two lines. So means that you're containing the first line. I just roughly draw that this is your L1 and this is your L2, right? So as you know that to find the equation of plane, we have to apply the formula of R dot n equals to A dot n, right? R dot n, A dot n. So, and I always tell you that if you want to find the equation of plane, you must have a point, right? You must have a point and a normal, right? A normal to the plane means that it's a perpendicular vector to this plane. So, how to find this? So, as we need two different vectors of maybe that are not parallel, and these two lines is actually having a different direction, right? So as you know that the direction of these two lines, so you can apply the direction of these two lines. Means that you have to get the information by looking at the direction for these two lines, because that the direction for these two lines is a vector, is a direction vector. When you're crossing these two vectors, any vector that on the plane, right? That on the plane. So you can actually crossing any vector on the plane to produce a normal vector. So for this case here, so before that I have to change the form into a parametric form, right? In fact, I like to change L1, the line 1 into parametric form. This is Cartesian form, right? So as I can just writing this to be as this is already using t, so we're using lambda as a parameter. Okay, 2 minus x is lambda, and y minus 1 equals to lambda, and 2z equals to lambda. So the purpose here is we want to get the direction, right? We want to get the direction from the equation. So from here, we know that x, right? X will be 2 minus lambda, right? Y will be -1 become +1 plus with lambda, and z will be lambda over 2. So this is a parametric form of line 1, the first line, right? So from here we can actually read the direction of this line, right? The direction of this line, which is in the ratio of -1, right? -1, 1, and 1 over 2, right? So if you rewrite this into vector form, you can see that for this part 2, 1, 0. Okay, I also can rewrite this in vector form, right? Let's write in vector form, so it's easy for me to explain later. So let's say this is line 1, right? The first line. So the first line in vector form, you can write as 2, 1, 0, right? 0 plus lambda over 2. So which is 0. 2, 1, 0, right? 2, 1, 0 plus with lambda of -1, 1, 1 over 2. -1, 1, 1 over 2, right? So this is a point on the line, right? And this is a formula for R is A plus TV, right? Lambda V. So this will be the direction vector of this line. And of course, we can also write the line 2 in vector form, right? Vector form, so that we can see what is the information that we can get from this line here. 3, 2, 0, 0 plus t. 3, 2, and 0 plus with t, right? T. Then the direction will be given by -1. The direction vector will be -1, 3, and 1, right? 3 and 1. So we have two lines, right? We have two respective lines. So now, so then later on, we already know the vector means that the direction for this line and the direction for this line. As these two direction, this vector is on the plane, right? As the line lies on the plane, because the question said equation of a plane that containing the lines, means that these two line contain means the two line is on the plane, right? It's on the plane. So, right, how to solve this problem, right? Alright, now let's continue, as I already give you some information where this plane containing two lines, right? So if I convert this equation into vector form, alright, as I know that this line were containing a point and this line also containing a point, means that for this question we have enough information, right? We have enough information because we want to use the formula for r dot n, a dot n. There must be at least a point on the plane is given, right? And you know that this plane containing two lines, right? And this line containing the point, right? This is the point on the line, right? It's one of the point on the line. So means that, okay, I can know that for line 1, there is 2, 1, 0, right? So that I write out all the information here into the diagram. So, and you have 3, 2, 0, right? So you have 3, 2, 0 also as a 2, 1, 0 and 3, 2, 0 is lies on the plane also, because the plane containing these two lines. These two lines means every point on the line is on the plane, right? So it means 2, 1, 0, 3, 2, 0 is on the plane. So now I want to using this information, this formula, I need to know the normal of the plane, right? Now we already know the position vector of A. You either can taking 2, 1, 0 as a point, as a position vector, or 3, 2, 0, either one. Alright. So now we want to find the normal vector. So I have already tell you that the normal vector you can using the two direction vector to do cross product. As you know that when you have two vector, you do cross product, and vector v1, any vector when you do cross product, they will produce a normal, a 90-degree vector to this plane, right? To this both of this line here. So it means that to find the normal here, we have to do a cross product. Either you taking v1 cross with v2, okay? Either you cross v1 cross with v2 or v2 cross with v1 is okay. Right, so okay, of doing the cross product, so we're using the method of expansion of the determinant. So just like determinant, so where is the v1, right? So the v1, I can taking this as your v1, right? This is a direction vector for this line, for the first line, right? And this will be the direction vector for the second line. So now I'm going to do cross product v1 cross v2. Negative 1, 1, 1 over 2, right? Negative 1, 1, 1 over 2. And followed by negative 1 over 2 and negative 1, 3, 1. So this is my normal vector. After I cross product, then I will produce a normal vector. So how to doing this cross product? Very simple, as you know that. How to do this? So positive, right, for this one, right? Just like you expand a determinant, right? Expansion of cofactor of determinant, positive I. So what is the minor for I here, right? Just like minor. So you have 1, 1 over 2, 1, 1 over 2, 3, and 1, right? Doing cross product. Negative, right? For this, you have negative, closing the row, the column here, negative 1, negative 1, 1 over 2, negative 1, 1, right? Negative 1, 1, J, followed by positive K, right? K. So closing the row, delete the row, delete the column, you have negative 1, 1, negative 1, 1, negative 1, 3, right? So later on, we have to calculate this 1 times 1, 1, right? 1. So 1 times 1, you have 1 minus with 3 times 1 over 2, so 3 over 2. So 3 over 2i and minus with negative 1 times 1, you have negative 1, right? Negative 1 times 1, you have negative 1. Minus with negative 1 times 1 over 2, negative 1 over 2, right? AD minus BC. So J negative 1 minus with negative 1 over 2 plus with negative 3 minus with negative 1 times 1 negative 1, right? This is the way you're doing cross product. So let's simplify. 1 minus 3 over 2, 2 over 2 minus 3 over 2, so negative 1 over 2i, right? Negative 1 over 2i followed by negative 1 plus half. Negative 1 plus half, you have negative half. So it's plus 1 over 2j, right? And for this you have negative 3 plus 1. Negative 3 plus 1 is negative 2, right? Negative 2k. Sorry, this is k, right? Negative 2k. So means we have already produced a normal vector to this plane, right? We have identified, we have known the normal vector to this plane as negative 1 over 2i, negative 1 over 2i, plus with 1 over 2j minus with 2k, right? So now we have already have information about the normal vector, which is negative half i plus half j minus with 2k by using cross product. Okay, later on, we want to find, after we have the normal, we have the point, right? Either one is okay. So we can find the equation of plane by applying this formula. Alright, okay, let's continue by finding the equation of plane by applying the formula for equation of plane r dot n. So where your n, your normal vector will be negative half I plus with half j, negative with 2k equals to, right, a dot n, a dot with n, right? So the vector a, the position vector of a, it will be any point on the plane, right? So I can choosing 2, 1, 0, right? 2, 1, 0 with the dot with the normal vector, right? The r dot n equals to a dot n. So a can be either these 2 points, either one. So normal vector will be negative half, right? Negative half, half, and negative 2 here, right? Negative 2 here. Okay, let's continue doing the dot product. 2 multiply negative half, you have negative 1, right? 2 multiply negative 1 plus with 1 over 2 plus with 1 over 2 and plus with 0 times negative 2, we have 0. So from here we can see that, alright, okay, r dot negative half I, right, negative half I plus with half j negative with 2k, right? Okay, let's simplify here. We were getting negative 1, right? Negative 1 plus half. Negative 1 plus half, you will produce negative 1 over 2, right? Negative 1 over 2. So, and this will be the vector equation. But usually I dislike to leave my answer in fraction form. Alright, and this is an equation. I can convert everything become integer. Alright, I want to avoid the fraction, but it's okay if you want. Alright, so I rewrite this to be in Cartesian form because the question just said find the equation of the plane, right? You can give it in vector form or Cartesian form. So I write it in Cartesian form. So what, negative 1 over 2, very simple. So I just write it become x and plus with 1 over 2j. The j now it's become y and negative 2z, right? Negative 2z, everything equals to negative half. So the best here is I'm going to multiply everything here. Multiply the equation right and left and right with negative 2. I multiply everything with negative 2. Okay, in my mind, all right, I multiply with negative 2. Multiply with negative 2, I have x, right? Negative 1 over 2. Negative 2, I have positive 1x here. So 1 over 2 and negative 2, I have negative y, right? I have negative y. Followed by negative 2 and negative 2. Negative 2 and negative 2 become positive 4z. And finally, negative 1 over 2 and negative 2, you are getting 1. This will be the Cartesian equation of the plane. Or if you want to write in vector form, it's okay, right? Vector form, it will be I minus with j plus with 4k is equals to 1, right? So this will be the equation of this plane, right? Equation of this plane, so which containing the two line here. Alright, so let's say the student said, sir, can I using just now, sir using 210, right? Sir is using 210. Can I using 320? Okay, you can try. So I've already tell you use either one. So you can use 320, right? The combination will be the same. 320 multiply. This is if, okay, you apply this point as your A, right? So negative 1 over 2 with 1 over 2 and negative 2. So you just multiply. You negative 1 over 2 multiply 3, you have negative 3 over 2, right? Plus with 2 multiply with 1 over 2, we have 1. 0 minus negative 2, we have 0. So you're getting negative 1 over 2, right? Can you see that? For this, you also get negative 1 over 2, right? The scalar, the same scalar, alright? You're still getting negative 1 over 2. Why? Why is this work? Why is this method work? When you dot, you're getting the same answer. Because these 2 points is fall on the same plane, right? Except if this 2 point is not on the same plane, then definitely this will be different, right? Alright. So you can stop the video for now, okay, as you already understand. But if you want to know more, I will continue to teach you something in this video, how to verify that this is true, right? How to verify that this two line is on the plane, right? Okay, this is for further information. Alright, what I want to talk about the further investigation of this problem is, let's say you like to know more, right? So if you have two line, right? So you have two line. You know that this is the equation of plane that produced by the plane that containing these two line, right? Containing these two line. So it means that if the plane is on the line, right? If the plane is on the line, in the previous lesson that I got talk about the concept of a line on the plane, right? How to show that a line on the plane. So show a line on the plane. I have talked about the concept, how to showing this, right? So now I'm going to show you how to show that if let's say this plane, this answer is correct, means that you want to know that whether your answer is correct or not. This plane means that, or you said that this plane containing these two lines, right? As long as you can prove that this plane containing these two lines, then you should be true, right? The plane, this equation of plane. So it means that the both equation, because this line I already rewrite in parametric form, alright? Parametric form. So let's focus on these two lines now. The first line and the second line. The first line I write in parametric form. So now I want to show that the x, y, z for this line, right? Will satisfy this equation of plane. Alright, okay, I do one for you. So as I already explained this concept in the previous lesson, so you try to refer to the video before you refer to this. It's very important here. So now x is let's say for line 1, right? We want to find the we want to show that this line satisfied this plane. Very simple. You just substitute the x, y, z general. So 2 minus lambda minus with y, 1 plus lambda, and plus with 4z, lambda over 2, right? We just use the constraint here, right? We don't look at here, alright? We just knew the linear combination here, right, of x, y, z. So we try to see, we have 2 minus lambda minus with 1, negative with lambda, 2, 2, 4 plus with 2 lambda, right? If you add up everything here, you get a 1, means that this line is on the plane. Alright, very easy to show that a line, very easy. You want to show a line on the plane, as I actually talked about this long-winded in the previous video, right? So now I'm going to simplify it. If you want to show that a line is on the plane, very simple. It will satisfy the plane by writing in the form of parametric form for the line, and you substitute the x, y, z into the algebra here. Then you will get the value of 1. Let's see, negative lambda plus 2 lambda. Negative 1 plus 2. 0. 2 minus 1? Yes, 1. Right? Satisfied. So it means that I have confirmed that line 1 is on this plane, right? Line 1 is on this plane. So this is for your knowledge, alright? For your knowledge. So it's for your knowledge. So let's say, okay, now I've done with line 1. How about line 2? Will it be on the plane? Definitely will, if my answer is correct, right? Definitely will, because this plane contains these two lines. So let's substitute the x, y, z into this plane, right? Okay, the second investigation. So the line 2, 3 minus t, alright? 3 minus t, I substitute into here, x minus with y, right? Minus with y, which is 2 plus 3t, right? Plus with 4z. The z is lambda over 2, right? Oh, sorry, the z is not lambda over 2, so be careful. 3 minus t, 2 plus 3t, the z is t, sorry, it's t. So now I just substitute 3 minus t, negative with 2, negative with 3t, plus with 4t. So how sure is it? Let's see. Negative t, negative 3t. Negative t, negative 3t is negative 4t. Negative 4t plus 4t? Negative 4t plus 4t? You are getting 0, right? So 3 minus 2, yes, you're getting 1 also. Can you see that? You're getting 1. And just now, the first line also getting 1, which satisfied the right-hand side, right? So this already show that these two lines is actually fall on the plane, right? So very sure this is the answer that for this question, right? But this is just for your knowledge, right? But the most important is you must understand how to what is the strategy to finding the equation of plane. First, you need to find the normal. First, you must identify a point on the plane, right? Alright, I think that's all for this video. Hope you understand.